We're never going to stop exploring the unknown in air and space.
Voyager, in some very real sense, is material that's not from the medium in which it finds itself.
According to NASA, the Voyager One probe is once again transmitting useful data to Earth. The silence of Voyager One has been disturbed by the prospect of aliens enslaving us in the vast, silent darkness of space. An unidentified object has sent a signal to the probe, an unexpected, perceptive response. This is direct communication from the depths of interstellar space, not a cosmic noise or failure. Who or what is outside? How might a neighboring object in space have sent Voyager One a worrisome reply? Voyager One, venturing outside of the solar orbit. Voyager One was launched on a Titan-Centaur rocket from NASA's Kennedy Space Center in Cape Canaveral, Florida, on September 5, 1977. The spacecraft set out on a journey that would transcend the boundaries of our solar system and go well beyond its original objectives. Voyager One's speedier trajectory carried it into orbit, paving the way for one of the most amazing adventures in human history, even though its twin, Voyager 2, had been launched 16 days earlier on August 20th. Exploring the gas giants Jupiter and Saturn was the main objective of Voyager 1, which it accomplished with remarkable success. When it came closest to Jupiter on March 5, 1979, it took amazing pictures and collected data. Voyager 1 followed a different route, while Voyager 2 proceeded to Uranus and Neptune. The spacecraft was launched out of the plane where most planets orbit the Sun after passing near to Titan, Saturn's largest moon. As it soared farther and farther away from the Sun, Voyager 1 continued to transmit back data as it embarked on its epic trek toward interstellar space. Despite expectations, Voyager 1 continued to operate for years. It became the first man-made object to enter the uncharted territory of the heliopause on August 25, 2012, the point when the influence of the Sun diminishes and the immensity of interstellar space begins. With this milestone, a new chapter in its journey began as it started to investigate the space between stars, providing data that had never been gathered by scientists before. Whispers of information are being sent back from the far reaches of space by Voyager 1, which is still traveling outward at an astounding rate of about 520 million kilometers annually. It presently travels at a 35 degrees angle above the planet's plane. The voyage of Voyager 1 is far from finished. The spacecraft itself will continue to float through interstellar space in silence, maybe for billions of years, even if its instruments will ultimately run out of power. By pushing the limits of our knowledge of the universe, its mission, now a part of the Voyager interstellar mission, embodies humanity's desire for exploration. We now have an unparalleled understanding of our solar system and the cosmos thanks to the Voyager probes. Our understanding of the interactions between the enormous span of interstellar space and the solar wind, charged particles that are continuously flowing from the Sun, has been greatly aided by these amazing spacecraft. The heliosphere, a massive bubble of charged particles that envelopes and shields our solar system and is sculpted by the forces of space beyond, has also been better understood thanks to the data from Voyager. To acquire a more complete picture of the Sun and how it affects the universe around us, NASA scientists have even integrated the data from Voyager with data from more recent missions. Our understanding of the limits of our solar system and the uncharted territories beyond has greatly benefited by this information. An emblem of perseverance. Given that Voyager 1 was a machine traversing the most hostile environment imaginable, space, its remarkable longevity and tenacity really come to the fore. Intense radiation, freezing or burning temperatures, and tiny space debris traveling at amazing speeds are all encountered there. Voyager 1 has endured for an incredible 47 years in spite of these obstacles. Its outstanding design, which is a direct reflection of the genius of the engineers and authorities who designed it, is largely responsible for its extraordinary lifespan. Voyager 1 was designed to survive continuous collisions from space junk, extreme temperature swings, and cosmic radiation. Its power source, nuclear batteries called radioisotope thermoelectric generators, or RTGs, makes it even more amazing. The heat from plutonium-238's natural disintegration is transformed into electrical energy by these generators. This procedure relies on a tool known as we actually use thermocouples in our daily lives in devices like refrigerators, air conditioners, and medical thermometers. They operate on the straightforward tenet that a closed circuit is created when two metal plates, each composed of a different electrically conducting material, are linked. An electric current is created when one of these metal connections is maintained at a higher temperature than the other. One of the metal plates of an RTG is warmed by the heat from the plutonium-238, while the other remains cold because of the planetary atmosphere or the coldness of space. RTGs are a reliable source of power for extended space missions because of the constant flow of electricity produced by this temperature differential. The RTG energy production of Voyager 1 has steadily declined over time, although it is still sufficient to power its scientific instruments. Voyager 1 is incredibly intelligent in addition to being robust. Like a scientific toolkit in space, it is equipped with a variety of advanced instruments. The cosmic ray subsystem, a high-gain antenna, an imaging science subsystem, a magnetometer, and a plasma wave subsystem are among the equipment on board. Many of the mysteries of the solar system have been solved thanks in large part to these sensors. In addition to finding active volcanoes on Jupiter's moon Io, Voyager 1 has gathered amazing data about the planet's strong winds and storm systems. Its investigation of Saturn showed that the planet's rings are teeming with intriguing features, such as spokes, ringlets, and twists. These tools have been crucial for researching cosmic rays, evaluating charged particles, examining magnetic fields, and detecting plasma waves in addition to the visual discoveries. A letter from Earth intended for any unidentified beings it might encounter in the future was a magnificent treasure carried by Voyager 1 as it raced through the expanse of space. The Golden Record is a priceless artifact that represents humanity's attempt to communicate with the stars. The sounds and visuals on the 12-inch, gold-plated copper disc known as the Golden Record are selected to highlight the diversity of life and culture on Earth. Like a time capsule from Earth, it tells the tale of our origins and identity in the hopes of establishing a connection with any sentient beings who may come across it. 116 pictures and a range of sounds are stored on the disc. It features our music's melodies, greetings in 55 different languages, and the sounds of nature, such as whale noises, bird songs, and thunder. A group under the direction of renowned astrophysicist Carl Sagan meticulously chose each item to symbolize the various civilizations and experiences of Earth. This unique communication is carried by Voyager 1 and its twin, Voyager 2. It's incredible to think that aliens might eventually discover these spacecraft. The discovery of Voyager 1 and the Golden Record by a highly developed extraterrestrial society might mark a turning point in our history of communication with other worlds. Here are 3 interesting scenarios that could occur. The aliens could first attempt to decipher the Golden Record by interpreting the sounds and visuals with their sophisticated technology. Second, they could send a response that reaches Earth by 2029 if they have the ability to travel across space or communicate across great distances. Scientists predict that humanity may make our first contact with extraterrestrials as early as 2029, which is not surprising. Third, in accordance with the principle of not meddling with other civilizations, a concept frequently discussed in science fiction, they might decide to study Voyager 1 without establishing contact. Whatever the outcome, any encounter with extraterrestrial life would be a significant development that would alter our perception of our position in the cosmos. Strange messages from the furthest reaches of space. After years of devoted service, Voyager 1's most recent discoveries have recently aroused fresh interest. NASA engineers are baffled by the data that the spacecraft has begun returning from the edge of interstellar space. The attitude articulation and control system, a crucial component of Voyager 1, appears to be the source of the issue. The steering and balancing system of the spacecraft is analogous to the attitude and articulation control subsystem, or AACS. In order for us to continue receiving data, it ensures that the spacecraft remains pointed in the correct direction, particularly with its large antenna directed toward Earth. Additionally, it aids with the spacecraft's rotation and positional adjustments. Additionally, it meticulously aligns the scan platform to guarantee that everything is in place for those crucial measurements and space photos. Oddly, the actual orientation and movements of the spacecraft no longer match the data from Voyager 1's AACS. In the vastness of space, the spaceship almost seems to have lost its sense of direction. NASA tells us that Voyager 1 is still doing its job well in spite of this strange behavior. From its remote position, it nevertheless receives orders from Earth and collects important scientific data. This malfunction appears to have no effect on the spaceship. Voyager 1 is not in protective mode since its onboard safety mechanisms have not been activated. Interestingly, the high-gain antenna is still pointed correctly at Earth, and its communication signal is still strong. But occasionally, the AACS data seems arbitrary or nonsensical, which adds to the enigma. Given the age of these spacecraft, such mysteries are to be expected, says Suzanne Dodd, project manager for both Voyager 1 and Voyager 2. No one could have predicted how far and how long Voyager 1 and its twin would travel. There will inevitably be some oddities and mysteries as they travel through the hostile, highly radioactive environment of interstellar space, a place that has never been visited by a spaceship. NASA's engineering team is facing a formidable obstacle, but they are hopeful that the spacecraft's AACS problem can be resolved. Voyager 1 encountered a similar predicament in 2017 when its main engines started to exhibit wear. In order to keep the mission alive and functioning at the time, the engineers had to turn on thrusters that had been inactive for 37 years. The latest development in the story is that NASA's clever engineers have identified the issue's origin. It turns out that the data was contaminated because the AACS was transmitting telemetry data to a computer that had long before malfunctioned. Suspecting this defect, the project manager moved on to diagnose the problem. By continually ordering the AACS to reroute data to the appropriate working computer, you are taking a calculated risk. The precise reason for the AACS's misdirection is still unknown. However, it is likely that a problem with another onboard computer caused it. This raises the possibility of a more serious underlying issue with the spacecraft. However, the engineering team does not consider this to represent a significant risk to the overall mission health of Voyager. The team is keen to learn more about the intricate systems of Voyager 1 as they attempt to solve these technological puzzles. However, it's crucial to understand that Voyager 1's space voyage is limited. Eventually, the spacecraft's mission will come to an end, which begs the fascinating question: how long can Voyager continue its incredible voyage over the vastness of space? To answer this, we must comprehend how Voyager 1 communicates with us from a staggering 24 billion kilometers away, and the variables that will affect our ability to stay in touch with this remarkable explorer for an extended period of time. The Voyager 1 Lifeline, a meticulously planned radio system that can operate both inside and outside of our solar system, is essential to Voyager 1's ability to stay in contact with us. A strong high-gain antenna, which is necessary for both sending and receiving radio signals, is at the heart of this system. The Deep Space Network consists of 3 Earth-based stations that communicate with this antenna. By connecting Earth to the furthest regions of our solar system, the Deep Space Network, or DSN for short, is a monument to human ingenuity and tenacity. The DSN, which is run by NASA's Jet Propulsion Laboratory, is a symbol of humanity's pursuit of space exploration and more than just a system of enormous antennas. Communicating with spacecraft traveling across deep space, such as the renowned Voyager 1, which is continuing its historic trip far beyond the boundaries of our solar system, is its main objective. Goldstone in California, Madrid in Spain, and Canberra in Australia are the 3 main DSN facilities, each of which is ideally situated throughout the world. This worldwide setup guarantees that there is always a DSN site capable of keeping in touch, regardless of where Voyager 1 is in its orbit. This well-designed network ensures that the spacecraft never loses connection when Earth revolves. Large, extremely sensitive antennas at each of these locations are able to detect even the smallest signals from the furthest reaches of space. Using its low-power radio transmitter, Voyager 1 transmits data back to Earth at a rate of 160 bits per second, which looks minuscule by today's standards. The great distance between Voyager 1 and Earth is the cause of this slow data rate. By the time it reaches us, the signal is extremely feeble because it is more than 14 billion miles distant. However, the antennas of the DSN are made to pick up these hardly noticeable transmissions. Each antenna is a huge parabolic dish that is specifically designed to focus and amplify these weak radio signals. These dishes can have a diameter of over 70 meters, 230 feet. The DSN uses cutting-edge technology to lessen the difficulties associated with deep space communication in order to accomplish this. In order to minimize noise and interference, The antennas are fitted with very sensitive receivers and advanced amplifiers that are cooled to slightly above absolute zero. This is important because electronic interference from the Earth itself and natural radio noise from celestial bodies can readily overpower Voyager 1's radio transmissions. To separate this noise and retrieve the useful information transmitted by Voyager 1, the DSN's engineers employ a variety of methods. A signal processing center is installed at each DSN station to handle and analyze incoming signals. After that, the data is sent to JPL for additional distribution and analysis. This procedure is essential for deciphering the scientific data and pictures that Voyager 1 returned, including information on the furthest limits of our solar system and beyond. Scientists can learn more about the heliosphere and the interstellar medium beyond it thanks to the data gathered. The DSN is an essential component of the Voyager 1 mission, which is a significant accomplishment in space exploration. In order to stay in touch with Voyager 1 as it travels beyond the outer reaches of our solar system and into interstellar space, the network has proven essential. Every signal from Voyager 1 represents a fragment of history, a moment in time of the spacecraft's journey over uncharted territory for humanity. Apart from assisting Voyager 1, the DSN remains an essential part of many additional space missions. Beyond communication, it can provide vital radar and radio astronomy measurements that further our knowledge of the cosmos. The DSN will be essential to NASA's Artemis missions, which are aimed at bringing people back to the Moon and eventually sending astronauts to Mars. Signals that fade direct communication with Earth has become more challenging as a result of Voyager 1's trip into outer space. The spacecraft utilizes a digital tape recorder with a capacity of roughly 67 megabytes to handle this. This implies that when communication circumstances improve, Voyager 1 will be able to store its data and relay it back to Earth. In 2023, Voyager 1 signals took more than 22 hours to reach Earth, while data from Mars rovers arrived in 15 minutes. As Voyager 1 moves farther away from Earth, its signal gets weaker, which presents another difficulty. A feeble 20-watt signal is used by the spacecraft to transmit data, and as it travels through space, the signal gets increasingly weaker. Nevertheless, having a sensitive receiver to pick up the signal is more of a problem than the signal's power. This is not a big problem because of the DSN. Voyager 1, a lone messenger on an indefinite mission, is drifting farther into the vast expanse of space every day. It gets harder to stay in contact as it gets farther from Earth. Communication becomes more difficult as a result of Voyager 1's signals traveling more slowly and taking longer to reach us. Theoretically, however, there is no limit to how far we could communicate with this adventurous adventurer. But there are limitations imposed by reality. We are running out of time to maintain communication with Voyager 1, and that time is measured in a matter of years. Furthermore, Voyager 1's electrical capacity progressively declines over time due to its nuclear power source. After Voyager 1 captured the iconic pale blue dot image in 1990, which depicted Earth as a tiny, in the immensity of space, engineers made the vital choice to preserve energy by shutting down the camera. Only 5 of the 11 original scientific instruments are still in use today. Engineers have had to make tough choices, like shutting off heaters and other parts, to maintain the functionality of these vital instruments. These remaining equipment act as our eyes and ears well outside the solar system, sending back crucial information about magnetic fields, solar winds, and cosmic rays in spite of these difficulties. NASA took action in 2022 to save energy and extend the Voyager missions until 2025. Instead of shutting down one of Voyager 1's science instruments this year, the space agency announced additional power-saving measures in 2023, extending its lifespan until 2026. While some instruments may continue to function until the end of the decade, more are expected to fail by 2025 or 2026 despite these attempts. This incredible trip is coming to a conclusion, and the last word from Voyager 1 is probably going to reach us by the middle of the 20s. These signals will reach the deep space network, but even these strong antennas have their limitations. NASA projects that, depending on how much power the spacecraft have left, the Voyagers may continue to communicate via the deep space network until roughly 2036. As we get ready for our last communication with Voyager 1, this will signal the end of an era in space exploration. But the key issue remains: How far into the unfathomable reaches of deep space will this incredible spacecraft adventure take it when NASA finally loses communication with Voyager? It's time for the subscriber pick of the day. Voyager 1 resumed its lonesome course, sending humanity's message into the empty space beyond our solar system's vast unexplored regions. It had been sending signals and getting nothing except the soft hum of space for decades. That is, until Voyager 1 unexpectedly received a concerning response from a close object in space one fateful day. When the odd signal started to decode, the mission control scientists were first dubious. It was a message they had never seen before. "Help us. We are the last of our kind." The message came from a dark metal ball that had just been spotted circling a far-off dying star. Once merely a blip on their radar, this object was now making an urgent appeal for help. The trajectory of the item indicated it was headed toward their probe, and Voyager 1's systems verified the message was a fake. As the team worked frantically to comprehend the consequences, the atmosphere in the control room became heated. Is this signal a real call for assistance from a highly developed yet in risk of extinction? Or was it a cunning ploy, a trap set up to draw them into a cosmic trap? The team was confronted with the disturbing reality that this could be the first direct interaction between humans and extraterrestrial intelligence as they considered their choices. But was it a warning or a chance for contact? The future of Voyager 1 will reach a significant milestone by September 5, 2027. 50 years of interstellar flight. At a remarkable speed of about 38,000 miles per hour, this legendary spacecraft has blazed a trail across the cosmos, venturing well beyond the boundaries of our solar system. By this time, Voyager 1 will be roughly 24 light-hours distant from the Sun, or 176 astronomical units away. The vastness of space and the amazing feat of human engineering and ambition are highlighted by this distance. Voyager 1 is still in the early phases of its interstellar trip, nevertheless, despite its amazing speed. To put this into perspective, it will take almost 300 years to reach the inner border of the Oort cloud, a far-off region of ice bodies that surrounds our solar system, assuming it continues at its current speed. It would take Voyager 1 almost 40,000 years to come into contact with another star. What might Voyager 1 encounter on its mission, and where is it heading over the next billion years? In practice, the spacecraft will have to deal with issues including heat cycling, cosmic radiation, and micrometeoroid hits. Over time, these elements could cause structural deterioration. Voyager 1 might, however, continue to float for hundreds of millions or even a few billion years. Voyager 1 will continue to travel through the galaxy, possibly passing by many stars and constellations like Hercules, Lyra, Cygnus, Draco, and Camelopardalis, provided it doesn't collide with anything large. Its path will be impacted over billions of years by a number of elements, such as gravitational interactions with passing stars, molecular clouds, and the tidal forces of the Milky Way. During this period, the galaxy will undergo tremendous evolution, with stars shifting from their current places and constellations either changing shape or going extinct. These uncertainties make it difficult to predict Voyager 1's precise course. Yet its voyage represents the pursuit of knowledge and understanding. Voyager 1 is an epic story of cosmic exploration that continues to symbolize humanity's curiosity and desire to explore the unknown as it journeys across the unexplored regions of the universe. A review of the Voyager expeditions lets take a moment to reflect on some of the Voyager spacecraft's amazing accomplishments. Launched in 1977, Voyager 1 and 2 were twin spacecraft with very identical designs. Television cameras, infrared and ultraviolet sensors, magnetometers, plasma detectors, and sensors for cosmic rays and charged particles were among the 10 scientific devices they brought with them. Their idea to investigate the outer planets before venturing into interstellar space was as audacious as it was revolutionary. On March 5, 1979, Voyager 1 made its closest approach to Jupiter, and on July 9, 1979, Voyager 2 did the same. These were absolutely groundbreaking visits. The cloud tops of Jupiter were within 217,400 kilometers of Voyager 1 and 6,180 kilometers of Voyager 2, respectively. Our solar system's massive giant, Jupiter, has never before shown its secrets. Jupiter's atmosphere, with its colorful bands and turbulent storms, was more complex and dynamic than scientists had previously thought. Jupiter's Great Red Spot was revealed by the Voyagers as a complicated, counterclockwise spinning maelstrom rather than just a massive storm. A picture of a planet experiencing continuous meteorological upheaval was painted by the spacecraft's detection of multiple smaller storms and eddies throughout Jupiter's banded clouds. But the most startling finding was that Io, one of Jupiter's moons, has active volcanoes. Scientists have seen active volcanoes outside of Earth for the first time. 9 volcano eruptions were recorded by the Voyagers, with plumes rising 300 kilometers above the surface of Io and material hurled at up to 1 kilometer per second. Tidal heating brought on by Io's gravitational interactions with nearby moons Europa and Ganymede, as well as Jupiter's powerful gravity, was thought to be the origin of this volcanic activity. The results went beyond Io. As far as the outer border of Jupiter's magnetic influence, the Voyager spacecraft found material from Io's eruptions seeping into the magnetosphere. This substance, which was mostly sulfur, oxygen, and sodium, had an impact on the entire Jovian system, causing UV auroras and aiding in the inflation of the magnetosphere. Another moon of Jupiter, Europa, offered a distinct kind of mystery. Intersecting linear features that were initially believed to be deep cracks were observed. Later, Voyager 2's high-resolution photos revealed that these features were exceptionally smooth, which would have meant that there was a thin layer of ice covering a liquid ocean. Europa is a prime contender in the hunt for extraterrestrial life because of the possibility that its ice covers a subsurface ocean. The largest moon in the solar system, Ganymede, has a complicated past. Its surface showed a combination of grooved regions and old cratered topography, indicating a dynamic past with intense tectonic activity. On the other hand, Callisto displayed a highly cratered, ancient surface that included the spectral remains of massive impact basins. A lengthy history of icy crust movement was indicated by the lack of topographic relief on its surface. Additionally, Voyager 1 and 2 made amazing discoveries near Saturn, with Voyager 2 making its closest approach on August 25, 1981, and Voyager 1 at its closest on November 12, 1980. Closer inspection of Saturn, which is renowned for its magnificent ring system, revealed minute characteristics that had not been seen before. It was discovered that Saturn's rings, which were probably produced by broken moons, contained a mixture of dust and bigger particles. The Voyagers saw how gravitational interactions with neighboring moons affected the rings' appearance and found unexpected structures like spokes and kinks. On January 24, 1986, Voyager 2 made its closest approach to Uranus as it proceeded on its journey. Due to its high tilt, Uranus had a surprising magnetic field. The Voyager's mission changed to include exploring the solar system's furthest reaches as they ventured beyond the known planets. Radio signals from the heliopause, the region where the solar wind and interstellar medium converge, were detected by Voyager scientists in May 1993. Our knowledge of the solar system has been drastically altered by the Voyager mission's unrelenting quest for information and groundbreaking discoveries. What developments are required to create new missions that will carry on investigating the outer reaches of space as Voyager 1 and 2 near the end of their journey? Please share your opinions in the comments section below.